We think gravity is simple, so we build rules around it. Fire rises, water drips, bodies rest on the floor, but remove gravity, and nothing behaves the same. So, a new plan to get rich quick. At 6:06 a.m., the diamond meteors pass overhead. They are weightless up there, so I'll just grab them, float back to gravity, and let gravity pull me back. So, trampoline up, grab diamonds, float back home. Exactly, space is easy. I'm invincible. Okay, got the meteors, now should fall back. Why am I not falling back? You're in orbit. Gravity is pulling, but you're moving sideways so fast you just keep missing Earth. So I'm stuck? Yep, unless you slow down with rockets. I have an umbrella. Well, then you are stuck. Oh no. So here's the lie. Astronauts float in space because there's no gravity up there. Nope. Fake news. Doesn't matter how many Hollywood space movies whispered this while playing Hans Zimmer violins. It's utterly false. Astronauts are floating in orbit because they are in free fall. They are constantly falling at high tangential velocity. And this is where microgravity comes in. It does not mean tiny gravity or gravity is almost gone. It means the effects of gravity, the normal force we feel pushing us into the ground, are minimized because everything is falling together. The International Space Station, ISS, zooms around Earth at roughly 28,000 kilometers per hour. It orbits Earth at around 400 kilometers above the surface, which might sound like in a galaxy far, far away, but that's still well within Earth's gravitational grip. In fact, gravity at the ISS's altitude is still about 90% as strong as it is on the surface. So inside the ISS, every single object, astronauts, water blobs, random crumbs of tortilla, even the air molecules, they're all falling together, accelerating toward Earth at the same rate. Because of that shared acceleration, no internal object feels a contact force. You don't press into the floor, you don't feel pulled, you feel weightless, but gravity, still there. Take a look at this tennis ball tied to the string and spinning it in a circle. The string is gravity. The circular path is in orbit. Cut the string and the ball flies off. It would be the same with ISS. If gravity weren't there, the ISS wouldn't stay in orbit. It would just shoot off into space in a straight line. But because of gravity, the ISS keeps curving around Earth. Kevin, my legs, they're noodles. My face, balloon, my brain feels like it's in a hot jello pool. That's just your body reacting to microgravity. Blood's pooling in your head, muscles wasting away. No, it's worse. I think I'm turning into what? A space zombie. That's not a thing. Brains. Also, maybe a labubu. I swear, if you bite the ISS, you're spending the rest of your life in intergalactic prison. Your joke's on you. I'll meet real heroes and ask how to be rich quick. Brains. Sup? Am I doing this pearl stitch correctly? The human body doesn't drain fluids the same way. Without gravity pulling blood down into legs, it pulls into the upper body. That's why astronauts get puffy faces and skinny chicken legs. It messes with vision and even reshapes the eyeball. Their bodies are confused. Even the cardiovascular system gets lazy. Bones lose density, muscles atrophy. This is why astronauts are required to work out 2 hours a day in orbit, to trick their bodies into thinking gravity still matters. Alright, today I'm finally getting that ugly photo of you, Moon. Why are you always showing me this side? Okay, Operation Space Balloon. Aw, cute. It didn't drift me around. Still my good side. Fine, and plan B, giant mirror shot. I'll angle all the space mirrors to catch the bad side. What the hell am I seeing now? Okay, maybe I have bigger problems in me than your backside. The moon is tidally locked to Earth, which means it always shows us the same face. A long, long time ago, not in a far, far galaxy, back when Earth was still a chaotic mess of lava, a Mars-sized object called Theia slammed into it. From that cosmic crash, the moon was born. At first, this baby moon was rotating way faster than it orbited, but gravity had other plans. See, gravity doesn't just keep things from flying off into the void. It tugs, it pulls, it distorts. Earth's gravity started yanking on the moon's slightly squishy insides, stretching it until the moon developed a tiny bulge facing Earth. And that bulge matters. Because the moon was spinning, that bulge kept slightly getting ahead of Earth's pull, so Earth's gravity would yank the bulge backward. That drag slowed the moon's rotation over millions of years. Why do I feel like I'm running in place? Because I'm gravitationally blocking your spin. You're welcome. Eventually, the moon's spin slowed down to the exact point where it rotates once per orbit. That means every time it goes around the Earth, it completes one full spin, keeping the same face turned toward us forever. This is called synchronous rotation. Tidal locking happens all over the universe. Tons of moons in our solar system are tidally locked to their planets. In fact, most moons are. Jupiter's got like 79 moons and half of them are already locked. I just don't want Earth to see my other side. It's not ready. But you have shown different angles of the craters. Maybe it's time to be vulnerable and move a bit more. I am vulnerable. That's why I stay locked. So moon does libration where moon does a little wobble. Because its orbit is elliptical, not a perfect circle, and the spin speed and orbit speed don't perfectly match all the time, we actually get to peak about 59% of the moon's surface over time, but never the full 100%. The backside, still permanently moon naked to deep space. Where the hell are we? Why isn't the car starting? I don't know why it's not starting. It blinked some red lights like twice. I felt like a party. Nicole, what did you do? Oh my god, I don't crash once. You know what? On June 3rd, 2018, 9:07 p.m., you forgot to pick me up and I had to walk in the rain. Okay, you know what? Let's just light a candle before I open the door. What the? Why is the flame round? Where the hell are we? Nicole, where the hell did you drive us? You see, here on Earth, flames have that pointy shape thanks to convection currents. Hot air rises, cold air falls. That's what gives candles that familiar pointy teardrop shape. The heat pushes upward, dragging fresh oxygen from below, and the whole thing becomes a flaming smoothie of combustion. But in microgravity, none of that works. No up, no down. So the hot gases don't rise. Instead, they just sort of hang out. So the oxygen doesn't come rushing in from below anymore. Instead, it diffuses in from all around. That makes the flame grow round, dim, and lazy. And the temperature drops too, by a lot. An average candle flame on Earth hits about 1,400 degrees Celsius at the hottest point. In microgravity, maybe 600 degrees, which also means less soot because the incomplete combustion that usually causes those black carbon particles. Alright, I'm out. Tell my light I loved her. He's still burning, I can still feel him. Dude, shut up, she'll hear you. Wait, you're still glowing without me? No, I mean, yes, but it's complicated. How do I always end up in situationships? NASA did this experiment called the FLEX, Flame Extinguishment Experiment, where they looked at droplet combustion in microgravity, and in some cases, the flame didn't even go out after it should have. After the visible flame disappeared, sensors picked up a low temperature burn still happening. This was dubbed cool flame. No, not like sunglasses wearing flame, but literally cooler temperature. It happens because some chemical reactions can continue at lower energy levels, especially when not disturbed by air currents or gravity pulling everything apart. Because these cool flames, they burn below 400 degrees Celsius, and they don't emit much light. But they can still consume fuel and oxygen, just way more slowly. So it turns out fire has multiple personalities, and microgravity just pulls off the mass. And of course, now we're dealing with flame stability in confined spacecraft environments. You do not want an uncontrolled flame up there with the oxygen tanks. That's why NASA's invested so heavily in understanding how flames behave in orbit. Because without gravity-driven convection, the fire doesn't self-extinguish nearly as easily. This is also why spacecraft interiors are lined with fire-resistant materials. Any combustion experiment is done inside sealed glove box chambers, because while fire might be slower in space, it's also sneakier. Alright kid, you testified against steam. Well now ice wants you gone. That guy is cold-blooded. I didn't mean to, I swear. They were just evaporating without a permit. Don't worry kid, you are now protected under the Water Witness Protection Program. You're going to space, you will be given new identity. Wow, no one will recognize me now. Water is made of 2 hydrogen atoms and 1 oxygen atom. Water molecules are polar, meaning one end is a bit negative, oxygen, and the other is a bit positive, hydrogens. That's why they stick together so well with cohesion via hydrogen bonds. Weak individually, powerful in mobs. On Earth, gravity usually wins and squashes water into puddles. But in space, no gravity, so surface tension is running the show. It only cares about molecules on the edge, so it forms a perfect sphere shape. Alright team, we've got no external forces, no containment, pull in, tighten the bonds. Surface tension is the phenomenon where the surface of a liquid acts like an elastic skin. It happens because molecules at the surface don't have any neighbors on top, so they cling more strongly to the ones beside and below them. The liquid pulls itself into the smallest surface area possible for a given volume. Mathematically, that's a sphere. That's why raindrops are almost spherical when they fall. Gravity just flattens them into teardrops before impact. In space, there's nothing to flatten them, so they default to the geometry of least resistance. And that's all for today. Thanks for watching.